let's begin. We have limit as x approaches negative infinity of 2x plus the square root of 4x squared plus 3x minus 2. Here, if I plug in negative infinity, 2x goes to negative infinity, and the square root goes to positive infinity. And here, we don't know what happens. So this could go to 0, or this could go somewhere else. So we're going to multiply this by the conjugate, the top and bottom, and we're left with limit as x approaches negative infinity. Now this is a, we'll call this a and this b. We have a plus b times a minus b, and so this is just a squared minus b squared by the difference of two squares. So this will just be 2x squared, right? So it'll be 2x squared, which is 4x squared. And then we'll have the square root of 4x squared plus 3x minus 2 squared, and the square root will just cancel. And this will actually be minus, not plus. Okay, so it's minus a squared minus b squared over 2x minus 4x squared plus 3x minus 2. The next step is to realize that we have a 4x squared minus 4x squared, so those will cancel. And this negative out here is going to distribute to the positive 3x and negative 2. So we have limit as x approaches negative infinity. It's going to be a negative 3x plus 2 over 2x minus the square root of 4x squared plus 3x minus 2. As x approaches negative infinity, I have positive infinity at the top, negative infinity, minus infinity at the bottom. So really this is not clear what's happening. So what I'm going to do is look at the greatest degree of the denominator. I see an x here and an x squared inside the square root. So I'm going to choose the one inside the square root. So I can think of it as just a square root of x squared. So the square root of x squared. And we know that the square root of x squared is absolute value of x because we know that the square root of x, the square root of x function, so y equals square root of x, it gives us a positive answer. Or unless it's 0, it gives us 0. But it's always going to be greater than or equal to 0. So if we just said square root of x squared is equal to x, and if x was, let's say, negative 5, we will not say that this is equal to negative 5. Doesn't make sense. So the output here is always positive. And obviously negative 5 is out here. It's not part of the domain. So that's another issue. But just know that the square root function will always give me greater than or equal to 0 as the answer. So that's why we want to put this absolute value to make it positive. But because we're looking at when x is approaching negative infinity, that means we're looking at a really, really negative number. So this absolute value of x is going to be negative x. Because if we look at the definition of the absolute value, it's going to be negative x if x is less than 0, and it's going to be positive x if x is greater than or equal to 0. And so if we're looking at when x is approaching negative infinity, we're obviously going to be in this case right here. So we can just choose negative x. We can replace, absolute value of x with just negative x. So going back to this problem, I'm really just multiplying everything by negative 1 over x. And so I have limit as x approaches negative infinity We have negative 3x times negative 1 over x, and that's just 3. And then 2 times negative 1 over x is negative 2 over x. 2x times negative 1 over x is just negative 2. And then the negative 1 over x can go inside the square root as just 1 over the square root of x squared. Because that's kind of what we were saying over here. So it comes inside the square root as 1 over x squared, which is really just dividing it by x squared. So you'll just have 4 plus 3 over x minus 2 over x squared. Okay, and now I see that 2 over x goes to 0, 3 over x also goes to 0, and 2 over x squared goes to 0. So what I'm left with is 3 over negative 2 minus the square root of 4, which is 3 over negative 2 minus 2, and that's negative 3 over 4. That's my limit. Yeah, this problem was very tricky. So you always want to be careful when you're approaching negative infinity that you have the square root of x squared be negative x, and if you're reaching, if x is going to positive infinity, you know that the square root of x squared will be positive x. Okay, so here we know that it's going to be negative x. All right, let's go to the next problem. We have limit as x approaches positive infinity as the square root of 9x squared minus x minus 3x. I already know it's infinity minus infinity, so I'm just going to multiply the top and the bottom by the conjugate. So we know that the square root of 9x squared minus x could be the a, and then 3x be the b. So we have a minus b times a plus b again. And so that would just be a squared minus b squared. So we have limit as x approaches infinity. The square root of 9x squared minus x becomes just 9x squared minus x. And then now we have a 3x squared, which will just be 9x squared, over the square root of 9x squared minus x plus 3x. The 9x squareds will cancel, so all that's left will be just negative x. So we have limit as x approaches infinity, and then we'll have square root of 9x squared minus x plus 3x. And right now we're still not done because we'll have negative infinity over infinity, so we want to simplify that as best as we could. So we're going to look at the x squared here on the bottom. We know that x squared is inside the square root of x, inside the square root. So we know that this is absolute value of x, which is x, because x is a really positive big number. So I can really just multiply top and bottom by 1 over x. So that will just be limit as x approaches infinity of negative 1 over. Now the 1 over x can go inside the square root as just 1 over square root of x squared. So essentially what you'll have is square root, actually, now let's try that again. So the 1 over x will become 1 over x squared inside the square root, and you'll be multiplying that by 9x squared minus x, and that will just distribute, so the 9's will cancel, and then you'll have negative 1 over x. And then when you have 3x times 1 over x will just be 3. Finally, we know that 1 over x goes to 0, and now you have negative 1 over square root of 9 plus 3, and that will just be negative 1 over 6. So our limit here is negative 1 over 6. Okay, the next one I have limit as x approaches positive infinity of square root of x squared plus 3x minus the square root of x squared minus 2x. Here it's infinity minus infinity, so that means we have to multiply by the conjugate. And for this one, we'll try to do this quickly since this is similar to the other ones we did. We know that it's a difference of two squares, so we'll have limit as x approaches positive infinity. A minus b times a plus b will be a squared minus b squared over the denominator. And the x squares will cancel at the top. And I have 3x minus negative 2x, which will just be 5x. The denominator stays the same. I have my limit as x approaches infinity. Okay, I see what's the greatest term in the denominator. That's the x squared. So we can think of that as just square root of x squared, which is just x in this case, since x is a really big positive number. So I can divide everything by just x, and the x will go inside the square root as x squared. So it'll be 1 over x squared times x squared plus 3x. And we'll have limit as x approaches positive infinity. And we notice that the 1 over x squared will distribute to these, so it'll just be 1 plus 3 over x. And then same thing here. That will just be 1 minus 2 over x. Notice that 3 over x and 2 over x will go to 0. So you're left with 5 over root 1 plus root 1. And my limit is 5/2.